So, thank you, Ben. Uh, Square theory is something that I came up once I was talking to another student, and it's related to the way I see the things. Basically, how technology is supposed to be to me. We will start with a not ludic sense, like just talk, and then we will jump into a React approach of Square theory. So to get started, I'd like to refer that, in my opinion, in my vision, everything is a square in technology. We can start by the pixels, the rate and the the height and the width and the rate of your screen are both sums of squares. Like your resolution is 1,000 squares for the left, 1,000 square for down, and everything's okay. All squares. So based on it, I want to relate about an experience I have once I was studying network computers. Uh, every request we made is addressed to something, and we give us our address to receive an answer. So what's this related to a square? Basically, we can relate it to a letter that generally is a square. We have me and Ben trying to talk, and we don't have technology. What we will make? A square. A letter. So we will address this to, I will address this to Ben, and Ben will address this back to me once he wants to answer the question. So I want you guys to think and tell me, anybody who wants in chat, I can see the CS chat, but I can't see, but I can see the conference chat of how you guys see out of the box without thinking about like how I have to make it. It's not a to-do list. How you guys see the relation about a component and a state in React? Exactly this question. How do you guys see about the relation of a component and a state in React? Can anyone show me a ludic way to see this? Does anyone have any opinion about it? Like how you see this? How you can relate it to something ludic, like real world? How you guys relate
I want to
it
make
in
sure I
your head?
understand. Are you saying the relationship between the component and the state?
Yes.
As in the store?
No, try to relate them without thinking in technical terms, like thinking about something real, something you can add it to it, like what is our component? What is the state? How they talk to each other? How they are related? States like the brain, and the component, the body / structure. That is a pretty interesting approach.
So the
What?
state, if I remember right, the state is the same as the store, right? Ben? I'm trying to remember.
No. I mean, like how Ryan told, like states like the brand. And
I
Allan is just referring to like,
yeah, I didn't.
like a metaphor, or what is like a.
I know, but I'm trying to remember. I'm trying to remember what the state exactly the same as the store in like the just the technical first. Just trying to remember.
Okay.
Okay.
So think about it. I like to see the component and the state as a door. So basically, not exactly thinking in the React working, but a door or any square. I think in my head comes a square. There is all comes a square. On-sit, a square, and the state referring it to the door is like the door is open, the door is closed, the door have a way to open it. I mean, they should be immutable things. The square, in my opinion, is an immutable. Can't be mutated. It's just a square. With the brain, we have disease, we have a lot of external associations that made us misunderstand the concepts. While with a square, you just keep a square. You can change it. It's a square. So how the state is related to a square? Its size, how much squares we are giving up, like 2 squares are 2 components. And this square is full, is empty, is big, is lesser than another one. So what exactly I mean to say with it? Think in technology in a way that is not exactly related to something that have mutable states, that have external factors, like, as I said, using the example of brain and body slash structure. I can break my leg. I would just make a big misunderstand if I try to think like in something that is mutable, any state, any real state. I like to think the technology, and as I talked in the beginning, this is just my my way to see the things, and it's a out of the box way to see the things. If I think like a leg, I will have external factors, external happens that can change my understood. So, repeating, I always think in technology as a square. So if you want to traverse an array, where you come? Another question, and anyone is free to answer. If you want to traverse an array, how you will draw the array inside of our head? Can anyone draw an array inside of our head once you are going to traverse it? Anyone? I think no, but it's okay. For me, an array is a square with squares inside of it. And each square is a position. So even the array pointer, like array, position is designed as a square. So I could be very wrong, but that is really related to squares, because square is an immutable storage way. If you store something inside of a square, or I mean, it could be water stored under the water box, like where you store water. I don't, there is a word, I'm sorry guys. Let me just check. Water reservoir. Yeah. Caixa de água. Yeah. This is like the way I mentally, visually, yes, Julian. I mentally visualize the data, like if we have an array of 3 positions, 0, 1, and 2, I will look at this like 0, 1, 2, with a big square out and little squares inside. So what is the meaning of it? Relating again to network, computer networking technician I've made, every time you pass an information over the network, it means HTTP and everything you learn after this, you are passing something like a ladder, very related to a ladder. So every information you made in network has an address directly related. That is the MAC address. That is too much deep, I'm sorry. But there is an address that only your computer has and only the other computer has. And there are a lot of middlewares that I don't go over. But every information we pass has a ladder, is like a ladder, has an address to go and an address to get back the information. So how does this apply to programming? I write it in the chat, a function that is like a callback. I'm almost done. So I write this callback here. So thinking it like a square that stores a function, a iteration with the machine, something that you go and make. It's like the Ben in the example of me sending him a letter. And the function that calls this callback is the other square that have his own address and they are talking. So basically, we try to give away the real world context and we put like a code and immutable. I put a code and immutable state to it, like it's pure code. You just look like a lot of squares. So how now I get enough square word talking, I relate it to the React word. I get can anyone see my screen?
Yep.
I can see it.
Yeah, Julian, absolutely. In my opinion, once you go to the memory allocation, you are talking about small pieces of squares. Small pieces, not now I do just change a little bit, not exactly a square, but a reservatory of anything. So you're basically talking about square that makes me easy. I basically talk about square that makes me easy. So once we go to memory, we have an exactly address directed to that request as it is with processors. And turning it into something we are learning right now, I came up with this Camel GitHub approach where we have a more advanced GIF than what Ben showed us yesterday, but it keeps telling us that everything is a square. Everything in the GIF is a square. Just the information that is not a square. But you can see like we have a square for action, we have a square for view where we call like the components or the containers. We have a square for a state. We have a square for a reducer for the reducers. And inside of the reducer square, there is another little squares that allows us to talk with the machine the way you want. So we are going like levels of square, going down and down and down until we reach the binary concept. So there are like levels of language that go one over another and keep resulting on binary translation. So basically, what if a reducer wants to talk to an action? He will get this information, will pass to the state, The state will pass it over and over till it reach the action. I mean, that is not exactly what happens looking like user looks, but looking like what machine does, and that is why I relate to Square, to don't have like, to be 100% abstract. It's a square. So as we can see here, even in the GIFs, squares. All I can see in technology are squares. I think that is all, because I don't have how to keep going this square thing, because it's just the way I saw the things. And I've passed it a little bit more than I want to, because that starts to tell you how to do, and I don't want this. I just want to share my way to see the things. So every time I need to solve a problem, I get a 3 or 4 squares in my head and try to make it talk with each other. That is why I figured that everything is a square or a ladder, if you want to think like this, and has an address and has an response address. Everything in computer. That doesn't matter if it's network, it's programming. A function call another function. Why we call this a block of code? Because it's a square. It's a block of code. So you get this block and put to talk to this one, that he turns to this one, so it has address. Basically, for me, it started with this square and it's going over and over. So now I'm more than in ladder. I'm in other way to see the things. But everything started with this square theory, like 10 years ago. And it's basically my own way to see the things. I think that is all. I just give up. I just came up with this React give, because you can look at anywhere. You will find squares. In computer draws, you will find squares, because they are pretty related to blocks, and the blocks pretty related to square. What is making the state go into the reducer? Yeah, sure. That's a good question, Emily. Once I send the state to the reducer, oh my God, I don't know exactly how to answer this to you. Can you help me, Ben? Emily just asked.
Making this state go into the reducer. So if you think of your reducers, there's two props, there's two parameters that you have in your reducer functions. So the first one is the property from state that the reducer controls. And then the second one is the action from the dispatch. So like when your reducer gets called, there's two things that are coming into the reducer function. One is the again, the property on the state that the reducer controls. The other one is the action that was dispatched. So like if you have an array of bunnies, then you have a reducer that controls the array of bunnies. Then when that reducer gets called, the array of bunnies gets fed in as well as the action that was dispatched. So then it determines whether or not it needs to change the array of bunnies. So anyway, that's why it has that little loop right there.
Thank you, Ben. If I can pause, yes. The thing is, that is all. I don't have any more. I just want to share my way to see the technology. So if you, Ben, want to tell something, or anyone, does anyone have any questions or any fun thing about this approach, anything to contribute? It's being pulled in as opposed to pushed.
Cool. All right. Well, thanks, Allan. That was really good. A good way to like visualize it. I know that with web development as well, or like with HTML specifically and how that's oriented on the page, there's this Mozilla add-on called Tilt, and it allows you to like shift the web page and see a 3D representation of it. And it's kind of cool because you see it as where like the HTML element and the body element, like or those tags are kind of like these big base tags, and everything else is built on top, and it's like a bunch of pyramids. And anyway, yeah, but it's like similar to this idea, you know, boxes and anyway, so it's always nice to hear different ways that people visualize this information and yeah, how they handle it. So cool. Thanks, Allan. That was great.
Thank you guys for watching.
Cool. All right.
Thanks, Allan.
All right. See you, everyone.